Hello, my name is Daniel, and today we will be going through the AMC 10A from the year 2013. And so let's get started. First thing, a taxi ride costs $150 plus $0.25 per mile traveled. How much does a 5-mile taxi ride cost? This is 1.5 plus 5 times 0.25. This is 1.5 plus 1.25, which is equal to 2.75. The answer is C. Number 2, Alice is making a batch of cookies and needs 2.5 cups of sugar. This is 5 over 2, right? Unfortunately, her measuring cup holds only 1/4 cup of sugar. How many times must she fill that cup to get the correct amount of sugar? And so this is 10 over 4, so she needs to fill 1/4 cup 10 times. The answer is B. Number 3, square ABCD has side length 10, so this is 10. Point E is on BC and the area of ABE is 40. What is BE? And so if this were a straight line, then this much area would have been twice, so this would be 80, and so this would be 8. The answer is 8. It's E. Number 4, a softball team played 10 games, scoring 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 runs. They lost by 1 run in exactly 5 games. In each of their other games, they scored twice as many runs as their opponent, so this means that they scored even number of runs. How many total runs did their opponent score? Okay, so in their other games, so then they scored 2, 4, 6, 8, and 10 runs in those games, and when they lost, they got 1, 3, 5, 7, 9 runs in, right? And so when the softball team lost, then the opponents got in 2, 4, 6, 8, 10, and then when the team won, they got in 1, 2, 3, 4, 5, and so when it's added together, it's 3 times 1 plus 2 plus 3 plus 4 plus 5. This is 3 times 15 equals 45. It's C. And then number 5, Tom, Dorothy, Sammy went on a vacation and agreed to split the costs evenly. During the trip, Tom paid $105, Dorothy paid $125, and Sam paid $175. In order to share costs equally, Tom gave Sammy $T and Dorothy gave Sammy $D. What is T minus D? Okay, so if they share costs equally, then each person would pay $135, right? And so for Tom to pay $135, then he should give Sammy $30, so that's T, and then Dorothy would have to make it to 135, so she would need $10 to give. So what is T minus D? It's 30 minus 10. The answer is B. Number 6, Joey and his 5 brothers are ages 3, 5, 7, 9, 11, and 13. One afternoon, two of his brothers, whose ages sum to 16, went to the movies. 2 brothers younger than 10 went to play baseball, and Joey and the 5-year-old stayed home. How old is Joey? Okay, so we know that the 5-year-old is like this, like it's staying, so it's not one of the brothers that went out. And then 2 brothers whose ages sum to 16, that could be 7 and 9 or 3 and 13. But then we need to have 2 brothers younger than 10 left over. So these two brothers is 7 and 9. Because that means that the 2 brothers whose ages sum to 16 are 3 and 13. So that means 11 is left. So Joey is 11 years old. It's D. Number 7, a student must choose a program of 4 courses from a menu of courses consisting of English, algebra, geometry, history, art, and Latin. The program must contain English and at least 1 mathematics course. In how many ways can this program be chosen? Okay, so if we take out English, algebra, and geometry, then we get these 3 left: history, art, and Latin. And then so because it said that we need at least 1 mathematics course, we need algebra and 1 of these, and 2 of these 3, or geometry and 2 of these 3, and algebra and geometry and 1 of these 3, right? And so this is choosing 2 out of 3, this is 3. This is also choosing 2 out of 3, this is 3. This is choosing 1 out of 3, this is also 3. If you add these together, then it's 9. The answer is C. Number 8, what is the value of 2 to the 2014th power plus 2 to the 2012th power over 2 to the 2014th power minus 2 to the 2012th power? This is, if we divide by 2 to the 2012th power on the numerator and the denominator, then this would be 2 plus, no, this would be 2 squared plus 1 over 2 squared minus 1. This is 5 over 3. The answer is C. Number 9, in a recent basketball game, Chanel attempted only 3-point shots, and at 2-point shots, she was successful on 20% over 3-point shots and 30% over 2-point shots. Chanel attempted 30 shots. How many points did she score? Okay, so let's say that she scored 20 3-point shots and 10 2-point shots, because that way it adds up to the 30 shots. And she was successful on 20% over 3-point shots. That means she scored 12 points here. And then 30% over 2-point shots. That means she scored 6 points here. So 12 plus 6 equals 18. The answer is B. Number 10, a flower bouquet contains pink roses, red roses, pink carnations, and red carnations. So I will make like this chart. Color would be pink or red, and the type would be roses or carnations. 1/3 of the pink flowers are roses. Okay, so this would be 1 to 2. So this is 1A, 2A. 3/4 of the red flowers are carnations, right? So this would be 3B. This would be 1B. And 6/10 of the flowers are pink. So 6/10 of the flowers are pink. So 3A plus 4B under 3A. This is 6 over 10. So that must mean A equals 2, B equals 1. So this would be 2 and 4 and 1 and 3, right? And so what percent of the flowers are carnations? So this is out of a total of 10. 7 are carnations, so that means 70% are carnations. The answer is E. Number 11, a student council must select a 2-person welcoming committee and a 3-person planning committee from among its members. There are exactly 10 ways to select a 2-person team. For the welcoming committee, it is possible for students to serve on both committees. In how many different ways can a 3-person planning committee be selected? Okay, so since it's possible for students to serve on both committees, then it doesn't matter what the first committee is. And then so there are and so if there are 10 ways to select a 2-person team, then n choose 2 equals 10. So this means that n is 5. And so a 3-person planning team is n choose 3. This is 5 choose 3 equals 10. So the answer is 10. It's A. Number 12, in ABC, AB equals AC equals 28 and BC equals 20. So this is 28, this is 28, this is 20. So D, E, and F are on the sides of AB, BC, and AC respectively, such that D, E, and EF are parallel to AC and AB respectively. What is the perimeter of parallelogram ADEF? Okay, so we need this length, right? But then we have these two. But we have these two lengths given because these are both 28, and we know that this length is the same as this length because this is an isosceles triangle, and the same thing because this is isosceles. We know that this length is the same as this length. So so the perimeter is the same as these two lengths added together. So this is 28 plus 28 equals 59. So the answer is C. Yeah, it's not 59, it's 56. It's 56, so the answer is C. Number 13, how many three-digit numbers are not divisible by 5, have digits that sum to less than 20, and have the first digit equal to the third digit? Okay. So if the first digit is equal to the third digit and it's not divisible by 5, then it's 1 something 1, 2 something 2, 3 something 3, 4 something 4. And you can't have 5 something 5 because that would be divisible by 5. So this is out. 6 something 6, 7 something 7, 8 something 8, 9 something 9. And 10 something 10 is not 3-digit. And then their digits have to sum to less than 20, right? So there will be 10 ways for this one, 0 to 9. Same thing here, 0 to 9, so it's 10. 0 to 9 is 10, 0 to 9, so it's 10. But then here we have 0 to so we have 0 to 6, right? So it's 6, 0 to 4, so this will be 0 to 8, this will be 8, 0 to 7, this would be 8, and this would be 9. No, actually, this is 0 to 7 because because it has to be less than 20, not less than or equal to 20. So this is 0 to so this value would be 0 to 7, this would be 0 to 5, this would be 0 to 3, this would be 0 to 1. And so this will become 8, and then 6, and then 4, and then 2. So these would add up to 10, these would add up to 10. 10, 10, 10, 10, 10, 10. The answer is 60. The answer is B. Number 14, a solid cube of side length 1 is removed from each corner of a solid cube of side length 3. How many edges does the remaining solid have? Okay, so this means that we end up with a shape like this, and then this is repeated. Yeah, so like that. And then how many edges does the remaining solid have? So first we've got to check the corners. The corners will be these parts, and then so they have 1, 2, 3, 4, 5, 6, 7, 8, 9 edges. This is 9 times 8, since there are 8 corners. And then we have the edges. They are these lines, and so there will be one edge, like still as if it was like a solid cube again. So edges would be just 12, and so this is 72, this is 12. If you add these up, this is 84. The answer is D. Number 15, two sides of a triangle have 10 and 15. The length of the altitude of the third side is the average of the lengths of the altitudes to the two given sides. How long is the third side? Okay, so let's say there are two sides of the triangle. There's 10, there's 15. The length of the altitude to the third side is the average of the length of the altitude to the two given sides. So let's say that this the altitude is 15a, and this altitude is 10a, right? So if you do this, so if you put a straight line down here, right down the middle, then it's the averages of the altitudes to the two given sides. So it's 12.5a, and so how long is the third side? So the, what do you call it? So the average is the same. No. So the area is the same, right? So this is 75 times 5. So this is 15 times 5. So this is 75a. No, 750a divided by 2. No. Yeah, so this is 15. This is 75a equals 12.5a. So this is 25 over 2 multiplied by 6, right? And so 6a. And then so this would be 12.5a multiplied by 6. So 75a is 12.5a multiplied by 6. And so how long is the third side? This would be half of this area is 6, so it's 12. The answer is D. Number 16, a triangle with vertices 6, 5, 8, minus 3, and 9, 1 is reflected about the line x equals 8 to create a second triangle. What is the area of the union of the two triangles? Okay, so let's draw the coordinates. The coordinates here, we won't need like that many coordinates, but we'll just have like an approximation. 6, 7, 8, 9, 10. This is 6, 8, this is 9. 6, 5, so this, let's say that this is 5, this is -3, and this is 1. Yeah, let's move 5 up a little bit. Like that much. And so we would have 8, -3, 6, 5, and 9, 1. So connecting the dots, it would be like this. No, 9 is here, just about here, right? And so connecting the dots, it would be like that, and like that to make this triangle. But then when we flip it about this line, right, then we see that it becomes exactly the same points. So it's these points, yes, it's right this point, and then so it also becomes like that and like that, right? So so this is what the total shape is, and the area of the union of the two triangles is the area of this. And so first let's divide this into two, just like this, and then let's multiply this area by 2, right? So first let's find this length. To find that length we need this point, and for that point we need to find x equals 8 in the graph, this, right? And so that contains 6, 5 and 9, 1, so that is y equals minus 4 over 3 x, and then 6, 5, so this is plus 13. So if x equals 8, y equals 13 minus 32 over 3. This is 13 minus 10 minus 2 over 3. So this is 3 minus 2 over 3. This is 7 over 3. Yeah, so this is 8, 7 over 3. Let's put this in red. 8, 7 over 3. And so 7 over 3 and this minus 3 would be 9, no, this would be 3 plus 7 over 3, this is 16, no, this is 9 plus 7, 16 over 3, and so the area of the union of the two triangles would be, this is 16 over 3, and this height would be 2, right? So it's 2 times 16 over 3 divided by half, because that's this one triangle, and then we need both triangles, right? So we need to multiply it 2, so these two cancel. This is 2 times 16, this is 32. This is 32 over 3, so the answer is E. Number 17, Daphne is visited periodically by her 3 best friends, Alice, Beatrix, and Claire. Alice visits every 3rd day, Beatrix visits every 4th day, and Claire visits every 5th day. All 3 friends visited Daphne yesterday. How many days of the next 365-day period will exactly 2 friends visit her? Okay, so if we say that Alice, so to find the number of days that only 2 of these 3 visit her, so we need to do Alice and Beatrix minus Alice and Beatrix and Claire, right? Because that will give us only Alice, Beatrix, and no Claire, right? And then for us to have no Alice, and yes Beatrix, yes Claire, that will be BC minus ABC, and for the same reason, just Alice and Claire would be, with no B, would be AC minus ABC. And so to get this, AB, this is 3rd day and 4th day, right? So this is 12. 12 minus ABC is 3, 4, 5. 3 times 4 times 5 is 60. Plus BC minus ABC. So what I mean by these numbers is number of, is divided by 12, right? Minus divided by 60, and then these are plus BC is 4 and 5, so it's divided by 20, minus divided by 60, plus AC minus ABC, that is 3rd and 5th, so it's 15, divided by 15, minus, and then third, fourth, and fifth. That is also minus divided by 60. And so we need 365 divided by 12 and all these stuff, right? That's what I was talking about right here. And so 365 divided by 12, that makes 30. And then minus divided by 60 is minus 6. Plus, and then 365 divided by 20 leaves 18. And then 18 and then minus 20 is as we said before, minus 6. And then plus, and then divided by 15 is 365 divided by 15. That is 12 times 2, which equals 24. 24, and then divided by 60, that is 6. So this is minus 6. So this is 30 plus 24 plus 18, and then these three come together, minus 18, so these two cancel. 30 plus 24 equals 54. The answer is B. Number 18, let points A equals 0, 0, B equals 1, 2, C 3, 3, and D 4, and D equal 4, 0. Quadrilateral ABCD is cut into equal area pieces by a line passing through A. This line intersects CD at some point P over Q, R over S. Where these fractions are in Lewis terms, what is P plus Q plus R plus X? Okay, so let's just let's just write out ABCD, and make the grid lines a little thinner, like that, and then and so 0, 0 will be here, 1, 2 will be here, 3, 3 will be here, 4, 0 would be here. So the lines would be like that, and like this, right? And so ABCD is cut into equal area pieces by a line passing through A. That line will be like this, right? So that this area is equal to this area, and so the total area of the whole quadrilateral would be total area. This is 4 plus 2 plus 1.5, right? So this is 4 plus 2 plus 1.5. This is 7.5. This is 15 over 2. And line intersects CD at P over Q, R over S. So yeah. And then this area would be, so the triangle would be, the area would be 15 over 4, right? 15 over 4, and then this would be same as this line times this line, right? Would be 4 times, let's say that this is h times 1 over 2, and so this is 2h, right? H equals 15 over 8, and since so h is 15 over 8, and so this would be something, 15 over 8. And for us to get this x value, then we need to know this line. So this line is, this is y equals minus 3x, and then we have it at 4, 0, so plus 12. So it's y equals minus 3x plus 12, and then if we if we substitute y equals 15 over 8, 15 over 8 equals minus 3x plus 12. 3x equals so 3x equals 12 minus 15 over 8. This is 12 times 8, 96, minus 15 over 8. This is 81 over 8. X equals 27 over 8. And so this is, and so this would be, so this would be 27 over 8, 15 over 8, right? What is P plus Q plus R plus S? So it's 27 plus 8 plus 15 plus 8. So this is 27 plus 8 is 35, plus 15 plus 8 is 23. This is 58. So the answer is B. Number 19, in base 10, the number 2013 ends in the digit 3. In base 9, on the other hand, the same number is written as 2676 to the power of 9 and ends in the digit 6. For how many positive integers b does the base b representation of 2013 end in the digit 3? Okay, so since the base b representation ends in 3, so this means that b is greater than 3. B is greater than 3. And if the base b representation is ending in the digit 3, then that would mean that 2013 minus 3 would be divisible by b, right? And this is 2012 and this is 2010, right? So if we dissect to 2010, this would be 2 times 5, so this is 10, and times 3, this is 2001 divided by 3, so that will be 6, 7. So 2 times 5 times 3 times 67, and so the base b representation of 2013 ends in the digit 3. So here so here the number of the, what do you call it, so the number of factors here would be there's one of each prime number, so this is 2 times 2 times 2, no, so the number of factors equals 2 times 2 times 2 times 2, but then we have to subtract 3 because 1 doesn't work, 2 doesn't work, and 3 doesn't work since b is divided by 3. So this is 16 minus 3 equals 13. The answer is C. Number 20, a unit square is rotated 45 degrees about the center. What is the area of the region swept up by the interior of the square? Okay, so we have a square like that, and then we have to rotate it. And so the area that we need to find is it's swept out, right? So let's say that it went this way. So it would have this much arc, this arc, this arc, and this arc more, right? So there would be this line, like this, and then this line, like this, and then this line, like that. And so what we need to get is these four are these yellow highlighted areas first, the ones with the arcs. So let's get those first. So these would be so if you add them up, they will be a half circle, right? So it's half of the whole circle, and since it's a unit square, the whole thing is 1, so half of it is 1 over 2, and so this much would be root 2 over 2, so this is 1 over root 2, and so 1 over 2 times 1 over root 2 squared. So this is 1 over 2 times 1 over 2 pi. This is 1 over 4 pi, right? So we have 1 over 4 pi, and then to get the part that is remaining, so we need the parts like this part, this part, this part, and this part, right? And so let's look at this one right here. Yeah, so if we look at that, that's made up of 2 of the same triangles like that, right? And so if you see closely, then this much is same. This is 1 over root 2, right? But then if we say that this is length A, no, this is length A, then this is also length A, right? But then since since this is A, this is also A, this would also be A, and so this would be root 2A, right? And so this much is 1/2, so A plus root 2A would equal 1/2. A times 1 plus root 2 would equal 1 over 2. And so a equals 1 over 2 times 1 plus root 2 over 1. This would equal 1 over 2 times root 2 minus 1. And so this is root 2 minus 1 over 2, right? So a is root 2 minus 1 over root 2. No, over 2. And so since and so now we can know this thing because we know that the height is root 2 minus 1 over root 2. So the triangle is, this bottom is 1 over root 2, and this times the height, root 2 minus 1 over 2, this times 1/2, and then we have 2 of these right here, this times 2, and then we have 4 of those, right? So this is times 4. So these two cancel, and this is 1 over, no, so, and then this will be root 2 over 2, right? And then this times the same thing, root 2 minus 1 over 2 times 4. These cancel, so this is root 2 times root 2 minus 1. This is 2 minus root 2, so the answer is 2 minus root 2 plus 1/4 pi. The answer is C. Number 21, a group of 12 pirates agreed to divide a treasure chest of gold coins among themselves as follows. The Kth pirate to take a share takes K over 12 of the coins that remain in the chest. The number of coins initially in the chest is the smallest number for which this arrangement will allow each pirate to receive a positive whole number of coins. How many coins does the 12th pirate receive? Okay, so the first pirate will take 1 over 12 of the whole thing, and then the second will take of what's left, so 11 over 12 is left, and then the second pirate will take 2 over 12 of that. Third will take 11 over 12 times this leftover, so 10 over 12 times 3 over 12 of that. The fourth will take 11 over 12, 10 over 12, 9 over 12, and then 4 over 12, right? And then all the way to the 12th, so the 12th would get 11 over 12, 10 over 12, 9 over 12, 8 over 12, 7 over 12, 6 over 12, 5 over 12, 4 over 12, 3 over 12, 2 over 12, 1 over 12, times 12 over 12, which is just 1, so we don't need this thing. And so, so the number of coins initially in the chest is the smallest number for which this arrangement will allow each pirate to receive a positive whole number of coins. So this means that we just need to simplify this whole thing, the 12th pirate, right? And so the coins that the 12th pirate would receive, this will be the numerator, right? Numerator, since the denominator would be number of coins, right? And so if we start to simplify this, 1 is gone, 2 times 6 is 12, 3 times 4 is 12, and 8 times 9, this is 3 times 4, so 3 and 4, and that gives us 1 more 12, and then and this becomes 2. And then 3 times 2 times 2 from here, so this would get 5, and then we get another 12. And so the numerator of this whole thing would be 11, 5, 7, and 5 multiplied. 11 times 5 times 7 times 5 equals 77 times 25. This is 25 times 7. 35, 14, 175, 175. So this would be 1925. So this would be 1925. So it's this. The answer is D. Number 22, 6 spheres of radius 1 are positioned so that their centers are at the vertices of a regular hexagon of side length 2. The 6 spheres are internally tangent to a larger sphere whose center is the center of the hexagon. An 8th sphere is externally tangent to the 6 smaller spheres and internally tangent to the larger sphere. what is the radius of this eighth sphere? Okay, so we have this big sphere, and then we'll have the 6 spheres inside it. The hexagon has side length 2, so this would be the hexagon, and then this would have side length 2, so that will be 2. So this would also be 2. So if we take that away, what we got is that the length of the center to that will be 2, and then the radius is 1, so this would be 1. So the whole radius of the big circle will be 3. And then this was just the top view, as I said. And then an 8th sphere is externally tangent to the 6 smaller spheres. So if we just copy this, and then get this over and make it like that, so this would be the same thing, but then we would also have one more sphere like that at the center, and then that would make it so it would be like this. And then let's say that this is r. Let's say that the radius is r. Then what we need is this kind of a triangle that we have to make. So you have to make this triangle. Let's have one more from here. And then since this is 1 and this is r, and then this whole thing is 3, this will be 3 minus r. 3 minus r. This will be r plus 1, and since the whole thing is 6, but then these two are 1, then this would be 4, and then half of that 4 will be 2. So this much is the same as 1 plus r, 3 minus r, and 2. So 1 plus r squared equals 3 minus r squared plus 2 squared. This is the Pythagorean theorem. R squared plus 2r plus 1 equals r squared minus 6r plus 9 plus 4. So these two cancel. 8r equals 8r equals 12. So r equals 3 over 2. The answer is B. Number 23, in ABC, AB equals 86 and AC equals 97. A circle with center A and radius AB intersects BC at points B and X. Moreover, BX and CX have integer lengths. What is BC? So let's try to draw a triangle like that, and then this would be about that long. Yes. And so a circle with center A, right? So we need a straight line like that. This is A, no, so this is A, this is B, and this is C. So AC is 97, this is 97, AB is 86, and then circle with center A and radius AB. This would be like that, and then this would also be 86. Oops, this would also be 86. Because this point would also be the intersection of the circle centered at A, so this point would be X. And just to add the circle would kind of look like this. It would be centered at A with B and X here, right? So this would, so this would be the center, and this would be it's kind of meeting points. And then it said BX and CX have integer lengths. So let's say that this is A and this is B. So so what we have to get is that length. So that would be let's say that this is H. H is root 86 squared minus A squared, right? And then if we use this triangle, 97 squared equals A plus B squared plus H squared. 97 squared equals A squared plus 2AB plus B squared equals 86. No, so that plus 86 squared minus A squared. So these two cancel. And then 97 squared minus 86 squared. This equals 2AB plus B squared. This is B times 2A plus B. And then this would be 97 minus 86. So that will be 11. times 97 plus 86, 183. So this is b times 2a plus b, but since b is this length and 2a plus b is this whole length, they are both integers, right? But then this isn't feasible because for this to happen, b would have to be 11 and 2a plus b would have to be 183. But then that's not possible because that wouldn't make a triangle. And then what we could have is 33 and 61. So that would that would perfectly give us what we want, right? Since b could be 31 and 2a plus b could be 61. What we're looking for is BC. BC is this length. This is 2a plus b. So 2a plus b is 61. The answer is D. Number 24. Central High School is competing against Northern High School in a backgammon match. Each school has 3 players, and the contest rules require that each player play 2 games against each of the other school's players. The match takes place in 6 rounds, with 3 games played simultaneously in each round. In how many different ways can the match be scheduled? Okay, so let's see that there's the Central High School team, and then their players are A, B, and C. And then the Northern High School team, their players are D, E, and F. So if we just make players A, B, C fixed, and to get who they will be competing against, then we can make it say D, E, F, and that would signify that A is matching with D, B would have a match with D, and C would have a match with F. And like D, F, D, E, this will mean that A is having a match with F, B is going against D, and C is going against E. So for each player to play one game against each of the other school's players in 3 rounds, that could be, it will be D, E, F, and then D, E, F, and then D, E, F, or it could be D, F, E, D, F, E, and D, F, E. So there are 2 ways for ABC to have this match with each of the other team's players once in 3 rounds. So let's label this set X and this set Y. This is X and this would be Y. And so the set could be X, XX, or it could be YY, or it could be X and Y mixed, right? But yeah, so XX would be, we have D, E, F, D, E, F, and then D, E, F, D, E, F, and then D, E, F, D, E, F, like this, except that this will be like all like randomized and the order will be different. So if that's the case, then we would be doing, then our number of possible outcomes would be 6 choose 2 multiplied by 4 choose 2, right? And then this would also be the same, since it's just basically the same thing with here. So it's 6 choose 2 times 4 choose 2. So this is 6 times 5 over 2, 15 times 4 times 3 divided by 2. This is 6. This is 30 times 3. This is 90. This is 90. And then XY mixed. That would be, these 6 are all distinct. They're all different, right? So there are 6 factorial possible ways. So that would be 720, right? So what we need to do is 90, 90, and 720 would have to be added together. 720 plus 180, this would equal 900, right? So the answer is 900, it's E. Last problem, all 20 diagonals are drawn in a regular octagon at how many distinct points in the interior of the octagon not on the boundary do 2 or more diagonals intersect? Okay, so let's try to draw this regular octagon. And then we need more, and then we need the 20 diagonals, right? But we don't want to have to draw all 20 diagonals. Helpfully we can see that we can divide this octagon into 8 different regions. like so. And then and then and then we could know how many points of intersection are in this one region, and then we can multiply that by 8. And so if we draw some of the diagonals, it will be like this, and like this. Oops. And then there could be like this and like this, and then these would intersect these two. So it's not very clear here because I've drawn the drawing a bit off, but then this would intersect these two. So if you take those out, then we get 1, 2, 3, 4 on the inside, 4 on the edges, and then 1 in the center. So let's add the one in the center at the very last, and then let's focus on these 6, right? Why these 6? It's because these 4 are on the interior, right? And then these 2 are on one side, right? And then for each side, this multiplied by 8 would have this. So this slice would be in charge of this side. This slice would be in charge of this side. This slice would be in charge of this slice. This slice would be in charge of this side, and so on until every side is covered. And so that would cover everything. If you understand what I mean, hopefully you do. So one slice has 6 points, and we have 8 slices equals 6 times 8 equals 48 points. But we can't forget this middle point right here, so 48 plus 1, that would equal 49. The answer is A. So that was problem 25, that was the last problem, and thank you for watching.